So they want us to find area with respect to y. Okay, this one is a lot easier from respect to y, because if you were doing top minus bottom, that would be a little confusing, right? You have, for some of it, the blue is the top, the red is the bottom, but then as you go to the left, then blue and the blue, right? You can do that, that's possible, but you'd have to break it up into two pieces. You'd have to break it up kind of like right there, and find the area here, top minus bottom, and then you could do top. This would be the positive version, that's the negative version. We'll do that later in the chapter, but it's easier just to do it right minus left, because it's pretty clear which one's the right, which one's holding in the area from the right, and which one's holding in the area from the left. So we don't have to break it up into smaller pieces. Okay? All right, so let's set up our integral. So, right, so the right is the red. Okay, the right was the red, y equals x cubed. But I can't put x cubed in there because it's only with respect to y. So I have to solve for x. Okay. So make it say x equals, right? So what would I do to make it say x equals? One step, what would that step be? Cube root it. So you get x equals the cube root of y. So when I plug it in, and remember it's a cube root, so it doesn't have to be plus and minus, just cube root's okay, because you can have negative cube roots. Okay, so the cube root of y, that's going to go here, minus the left. Well, the left is already in x equals form. It's already ready to go, so we can put y squared minus 3. dy. Last thing is the bounds. So remember, when you're going, when you're doing with respect to y, and it's right minus left, the bounds are going to be bottom and top y value. Okay, bottom and top y value. So this one of them is kind of easy to tell, but the other one is not. So go to your calculators. I want to figure out what is the y value for each of these guys. I think one is -1. But the other one is like 1 point something, and I'm not quite sure. 1.793. 1.793. Okay. So -1 and then 1.793. Those are the y values. Bottom y value, top y value. Okay. With respect to y, we always use the y values. Okay. All right, put that in your calculator. Round to the nearest hundredth. If you need to, I don't think you need to on this one. I think it's... Remember, instead of y, you could put x. It's okay. X squared minus 3.
Yeah.
Or minus 2. Yeah, you're right. X squared minus 2 should be 2. X squared minus 2. Yeah, I don't know why I wrote 3 up here as well. Okay. Okay, so that's with respect to y. So I'm going to give you one. I'm going to give you one more. I'm going to give you one more problem to do, so you can either on the bottom of that page or in the back of the page, there's also room on there. We'll call this example number 7.
This is 7.
8, sorry, 8. I want you to decide which you want to do. Would you rather do with respect to x, or would you rather do with respect to y? You can do both, but I would choose the easiest way. Choose the easiest method for you, okay? So here we go, last one right here. So find the area bounded by f of x, g of x, and the x-axis.
With respect to y.
So if we do it with respect to y, you could easily tell which one's like right and left, right? Right and left. I agree there, 100%. Like by looking at the graph with respect to y would probably be easiest. But then if we look at our functions over here, g of x is linear. I can solve. This is really y, right? This is really y. These are y's. Right. For negative 1.5x plus 9, we would just subtract 9, divide by that. We could solve for x, right? How do you solve for x if it's a quadratic? It's a little more difficult, right? Because there's multiple x's. So I would say for that reason alone, I would probably do top minus bottom. Okay? So yeah. But with that comes a few wrinkles, right? You can, maybe you kind of see it. So let's start with the top one. Let's call this one R1. Okay, so let's start with R1. So R1, which of those would you consider the top, the red or the blue? The red. I would consider the red the top. So the red is the quadratic, right? The red is f of x. So I'm going to put f of x in here, but when I put it in my calculator, I'm not going to do that. I'm just doing it to save space. Minus g of x, right? And then we got to find those two x values, those two black dots there. We got to find out what those x values are. So figure out where this guy and that guy are. X value related. So you're gonna look for where the red and the blue intersect. Okay, so real quick reminder on that. I showed you that a couple times, but let me show you one more time. Since this is the notes, let me take the time to do that. So you go back. So if we want to find points of intersection, you're going to go up to calculate. Right under where it says graph, it says calculate. So you're going to scroll up to calculate. Pick one, pick either the red or the blue. Doesn't matter which one. And then we're going to say, hey, I want you to find, oops, not, why did I choose that one? I want you to find points of intersection. Now there's multiple points of intersection. So it's going to give us all of them. Well, the first thing that red encounters green, right? We don't care about that one. So we hit the little cursor to the right, and it goes up here. That's the first one we care about, right? That x is negative 0.4, let's see, negative 0.4538, comma 9.6807. That's the first one that we need. And then I'm going to scroll one more time, and it's going to hit the other one. That's the second one that I need there. So that x value is 2.2038 and 5.6943. Okay. So that's going to be my lower bound, upper bound. Lower bound, upper bound. Okay. So we have negative 0.4538 to 2.2038. Okay. So you put that in your calculator. Like I said, instead of f of x, put the actual f of x, but I just did that to kind of the safe space. So when you do that, you're going to get that. Okay, so that top little sliver R1, that one's taken care of. So now let's go to R2. That second little triangle looking sliver down there. Top minus bottom. Top minus bottom. Well, blue is the top, but green is the bottom for part of it, and red is the bottom for part of it. So we got to break that up into two smaller spots, two smaller pieces. So here, that's R2, that's R3. Because in R3, blue is the top, red is the bottom. R2, blue is the top, green is the bottom. It's not always blue and red or blue and green. At that point right there, looks like somewhere right before 4, where x is 3 point something, it's going to be, okay? So let's set up a couple more here. So for R2, let's do R2 first. R2 is blue minus green. Okay, so blue is the line. Blue is g of x, so it's going to be g of x minus the x-axis, which is y equals 0. So now we got to figure out where the left and the right bounds are. Okay? The left bound is going to be that dashed line there, right before 3. The right bound is going to be where the blue and the green intersect for the last time. Okay, so we got to go now and figure out where those two intersect, just like we did before. So the blue, so how are we going to find this first dot here? What would we ask the calculator to do?
Find the intersection between red and green.
Yeah, find that intersection between red and green. And you're going to get 3.29. 3.29. And then over here, that guy is going to be 6. And then we also need this guy here too. Just realize that we need this guy here because the left bound for this, for R3, the left bound's going to be here, the right bound's going to be the dashed line. For R2, the left is going to be here, right is going to be here. Okay. And that guy is that x value here is 2.204. 2.204. Okay. Those are all the x values. So we're working on R2 right now. So R2, the left bound is going to be, we know it's blue minus green, g of x minus 0, and then 3.29 to 6. 3.29 to 6. Okay. And then the last R3 R3, blue is the top, but red is the bottom. Blue is the top, red is the bottom here. So blue is g of x. Red is f of x. And green was the x-axis. Okay, so we're going to go blue minus red dx. And the bounds are going to be from 2.204 to 3.29. And there you go. Okay. It's rare that you will have to divide them up that much. There will be some that give you like, it's pretty common to have some where they have two separate areas, two separate yellows. That's pretty common. But to have to break one of those up into two, that's rare. Usually it's just find the area of this area, find the area of this, add them up together. It's not all the time. That's why I wanted you to put one in like this in your notes, because so you have it, okay? Because there will be some times when there's two different areas that you have to find. But like I said, it's pretty rare that you have to actually break it up like that, like we did on this one, okay? So when you put those into your calculator, R2, wait, did I do something wrong here? Why did I put R2? Let's see, R2, 3.29 to 6. And then 2. Yeah, okay. So altogether, grand answer, when you add them all up, I did it a little differently last year, so I don't have the exact, but I have the grand total. It should be 4.3815. Let's see. Okay, let me go through. Let's see. Maybe I did it wrong last year. Let's see. Now I don't need this calculation. Okay. We have so the first one was R2, which was from 3.29 to 6. And that was g of x minus 0, right? Negative 1.5x plus 9. Oops, yep, I did something wrong. So that one is 5.5081. And then the next one was from 2.24. And then 3.29, right? And then that one, we had g of x minus f of x, yeah. So parentheses, negative 1.5 x squared plus 9, parentheses, minus the quadratic, which was negative x squared plus 0.2, 5x plus 10. Negative number. I get a negative number there. Did you guys get a negative, or did I do something wrong?
Well, you put 1.5x squared.
Ah, squared. Yeah, thank you. $1.995. All right, now we're working. Okay, so let's go back here now. Okay, so first one was 5.508. 5.5081, and then the last one we just did was 1.9950 for a grand total of, what'd you guys get? 10.64?
624.
624?
Oh, 62460.
Okay. 60. So let's put another 6 there.
63.
Perfect.
Yeah, I picked up later.
Okay. And that's area. Area between curves. Okay.